So if we look at the acidity of alcohols, such as methanol and ethanol, the smaller molar mass alcohols that would dissolve in water, where acidity would make sense, they are about as acidic as water itself, which means they are really not that acidic at all. So if we look at the hydroxyl hydrogen, it can dissociate in water to give an alkoxy anion anhydronium, but the Ka is about 10 to the minus 15th. So that's a weaker acid than water would be. Phenol, on the other hand, is more acidic. This anion, the phenoxy anion that forms, is stabilized by the aromatic ring. And so phenol has a Ka of about 10 to the minus 10th. So that's more acidic than water would be. Just like we can form hydroxide in water by adding highly reactive sodium to water, we can also form methoxide in methanol by adding sodium to it. We have to add a really reactive metal to get this anion, which is incredibly reactive and not that stable. So phenol, on the other hand, we can add just sodium hydroxide to it to form its conjugate base. And so phenol does act more like an acid than either methanol or ethanol. So here in your textbook, it has here the Ka of phenol, which is about 1 times 10 to the minus 10. And the larger this value is, the more acidic something is. In water, Kw is about 1 times 10 to the minus 14th. So this is 10 to the minus 10th is larger than that. So phenols are more acidic than water. However, methanol and ethanol are a little bit less acidic than water, with Ka values near 1 times 10 to the minus 15th.